Welcome to ClickMyProject.com. Now we are going to discuss about cybersecurity in power systems using Meta-Heuristic and deep learning algorithms. Now let's see the abstract of this project. Supervisory control and data acquisition, that is SCADA system linked to intelligent electronic device over a communication network, keeps an eye on a smart grid's performance and safety. The lack of algorithm protecting the power system communication protocol make them vulnerable to cyber attacks, which can result in a hacker introducing false data into the operational network. This can result in delayed attack detection, which might harm the infrastructure, cause financial loss. Similarly, attackers may be able to feed the system with a fake information to the operator and the algorithm into making bad decisions at a crucial moment. Traditional supervised machine learning algorithm like ANN, and here we are using the MLP, is a simple ANN, and random forest are measured with the proposed algorithm to demonstrate the effectiveness of the algorithms. Now let's see the flow diagram of this project. Initially we are going to load a data set. We are collected from the Kaggle website. After selecting a data set, we are going to load the data set into the pre-processing step. Pre-processing is nothing but removing null values and replacing those null values with a 0, or we can also remove the irrelevant data. So after successful pre-processing, we are going to split the data. So data splitting is nothing but splitting into train and test. Most of the data will be in the train and the remaining will be in the test. So test data will be used for evaluation. And after a successful splitting, we are going to apply algorithm on those data. The algorithm here we are using is MLP and random forest. MLP is a multi-layer perceptron, and random forest algorithm. Random forest is a machine learning algorithm, and MLP is a deep learning algorithm. MLP gives more accuracy than the random forest, so we are going to predict using a MLP algorithm. Performance analysis here represents the accuracy, precision, recall, and F1 score. Now let's see how the project works. So now the dataset selected contains this much of rows and this much of columns. After that we are going to do a pre-processing. Pre-processing is checking for missing values. There is one missing values in the time column, time field. So it has been replaced with a 0. So now we are going to split the data set into X train, Y train, X test and Y test. So these are the data in the X train, contains 1750 rows and 53 columns, and the last label column class variables will be splitted in the Y train, and the X test contains 438 rows. It is splitted in the ratio of 80:20. So these are the values in the Y test. So after that we are going to do applying algorithms on the data. So random forest algorithm gives accuracy about 90, and this is a MLP algorithm. MLP algorithm is applied. So the algorithm produced by the MLP algorithm is also nearly 90. So random forest algorithm gives less accuracy than the MLP algorithm. MLP algorithm produces a 90% and above. Random forest algorithm produce 89%. So this is the comparison graph of both the algorithms. So it is predicted as a masquerade, and these are the variables. And so this is the initial data frame which contains null values, and also it here we are not done the label encoding. Here we are not done the label encoding. X test value, X train, Y test, and Y train.